Hello and welcome to this DIY audio by Artiphysics video. My name is Dr. A. No, I'm not a proctologist. My degree is actually in engineering, believe it or not. And in this video we will continue with 3D printed loudspeakers. In the previous video we showcased our first two speakers that we've made. Those were part of our quest to develop and build a small and practical desktop loudspeaker, and we presented the FR1 and the FR2, which were full-range loudspeakers using Mark Audio drivers. And the FR1, it was small and practical, but it lacked in bass extension. The FR2 used a larger driver, a larger enclosure. We got some more bass, but still we felt that it's going to need a subwoofer. So over here we have the continued development showcased by the FR3s, which is a full-range loudspeaker using the Dayton Audio RS100 driver. It's a spherical enclosure standing on a tripod. And to complement the lower end, we have a 3D printed subwoofer also with a passive resonator. Let me go through some of the details of our concept here. Starting with the FR3, we have a minimum edge diffraction enclosure, or MEDE. It's kind of similar what Genelec has with their MDE, but we added one letter to the acronym. It's a spherical enclosure, so minimal edge diffractions. We wanted to bring the driver higher up from the desktop, so the FR2 was still on a tiltable isopod, but it was low down. So for the FR3, we used lead screws to develop a tripod that can be adjusted. The SW1 here is a subwoofer with a plate amp, 2.1 plate amp, and it's made in two parts with the parting plane here, and each part houses a 6.5-inch driver. The bottom one is active, the upper one is passive. The passive resonator here can be tuned also depending on your room response, for example, or the desired characteristics, but it plays down to approximately 50 Hertz. If you're worried about force cancellation, you can also mount the top part 180 degrees opposite of the lower part, and that way you get some force cancellations of the cone movement. But this 6.5-inch driver doesn't have a very heavy cone, so I'm not worried about force cancellation too much, and I had these drivers face the same direction. The FR2 used a carbon fiber shell to increase mass and stiffness. It looked really nice, but it was a lot of work. So as a DIY project, it's maybe not that suitable to have a carbon fiber shell. So for the FR3, we went with a steel-filled filament. So we get added density and added rigidity. And we used as much as possible of the filament. That is, we used internal structures or supports, even if the overhangs did not require it. It was simply to add more mass. And that way we get the part in one piece directly out of the printer. And all the post-processing that we did with this one was sand it. For the SW1, we used PLA because we needed a lot of material and PLA is quite affordable. We used in total 4 kilograms of filament printing this. It took about 100 hours in total. And to add even more mass and stiffness, we had some openings in the back where we poured in some epoxy and silicon carbide mixture, and that added about 2 more kilograms to the mass. Let's then have a look at what components we're using. Like I mentioned, this is the RS100 full-range driver by Dayton Audio. It's quite popular in the DIY scene, and I can now see and hear why. It's a very, very good driver. I like it a lot. The Mark Audio drivers we used in the previous builds were really good in certain types of music, but not, for example, for rock and metal music. But these, however, are quite nice with all kinds of music. The SW1 uses Dayton Audio DSA 175 active and passive drivers. And then in the back we have a 2.1 plate amp by LePai. It's a PartExpress product. It has a fixed high-pass filter and an adjustable low-pass filter. All right, so how do these sound? I'd say pretty damn good. The RS100s play the mids and the highs really nicely. The subwoofer is a must. You might think that, well, it's not really a subwoofer because it only plays down to 50 Hertz. You might think that, yeah, you can do without it. No, that range from 50 Hertz to 100 Hertz, it's really critical to get that warmth and that kick to the sound, and this really delivers it. The 6.5-inch drivers are enough. At louder listening levels, there is clear cone excursion, but it's not reaching its limits yet. So I'd say that this 6.5-inch driver is enough for normal listening conditions and even cranking up the volume every once in a while. If you want to build your own, just go to Thingiverse and download the STL files and print your own loudspeaker enclosures. If you want to support our channel, just click on the affiliate links in the description when you're ordering parts from Sound Imports. That way you're supporting our channel and it won't cost you a dime. That's all for now. Thank you for watching and stay tuned for our next projects.